On this video, we're going to talk about the properties of ellipse and their graphs. Let's start with the definition of an ellipse. So here is the definition. In mathematics, an ellipse is a plane curve surrounding two focal points, such that for all points on the curve, the sum of the two distances to the focal points is a constant. As such, it generalizes a circle, which is the special type of ellipse in which the two focal points are the same. So let's discuss the parts of an ellipse here. So this part is what you call the major axis. Along the major axis, you can see here the two focal points. Those focal points will show you how elongated your ellipse will be. The farther they are with each other, the longer or the more elongated your ellipse will be. And along the endpoints of your major axis is what you call the vertices. Then, this side is what you call the minor axis. On the endpoints of the minor axis, you have what we call the co-vertices. If you get the half the value of your major axis, you will have the value of your A. The value of your A can be found on your equation on the ellipse, as well as the half of your minor axis, which will be the value of your B on the equation. So let's proceed with the equation of ellipse. So in here, we have two types of ellipse, which is the horizontal and the vertical ellipse. It is very important for you to identify first which type of ellipse is given, knowing that you only have the equation here. It is because if you don't know what type of ellipse is given, you will have wrong answers, or you will not know how to get the value of your vertices, co-vertices, foci, and other parts or properties on your ellipse. So how can we know if it is horizontal ellipse or vertical ellipse? So here is the clue. You just need to look at your denominator. The higher denominator, you have to identify which variable it comes with. So if the higher or the highest denominator comes with x, it will be horizontal. If the highest denominator comes with y, it will be vertical. So if your ellipse is horizontal, this will be the formula for you to be able to know the values of your vertices, or v sub 1 and v sub 2. The clue here is if it's horizontal, you will add and subtract a on each. Then just copy k. Then you will do the opposite for the co-vertices. For the co-vertices, you will minus or add from k, and you will use b. So where do we get a and b? So a will be the square root of this part, or square root of a squared, and b will be the square root of b squared. On your foci, you have here the value of c, but we don't know what is the value of c. It's not shown on your equation, so what you're going to do is to solve for it. And the formula for you to be able to know what is the value of c will be equal to the square root of a squared minus b squared. Do not confuse this with the Pythagorean theorem. So we will use this formula in finding the value of c. That will be the square root of a squared minus b squared. If you will deal with the vertical ellipse, you will do the opposite of this one. So if you subtracted from h here, in here you will subtract from or add from k. So it will be the other way around for both of them. That's why it's very important for you to know which type of ellipse is given first before you found out the values of the vertices, co-vertices, and foci. For the major axis and minor axis, you just need to get the twice of A for the major axis and twice of B for the minor axis. Let me give you more examples for you to be able to have more deeper understanding with the properties of an ellipse. For your first example, what we have here is x squared over 36 plus y squared over 16 is equal to 1. So first we need to identify if this is horizontal or vertical. So the highest denominator here is 36 and it comes with x. So if it comes with x, you will know that this will be a horizontal ellipse. For your second step, you need to know what is the center of your ellipse, or you need to identify the center of the ellipse. If it's only x squared, meaning your h here is 0, and if it's y squared only, meaning your k here is 0. So meaning the center of your ellipse is at 0, 0, wherein h is equal to 0 and k is equal to 0. So we will locate it here on your graph, so you will see. So center at 0, 0. Next will be identifying the value of your a squared. A squared is always the highest denominator. For this case, we have 36. If you wanted to know what is the value of a, you will just get the positive root of 36. So meaning, this will be 6. Then the lower denominator, that is the value of your b squared, which is 16. And if b squared is 16, meaning to say your b here is 4. So we already have the value for a and the value for b. Next, we'll be finding out the value of c. For the value of c, you will just get, or you will just use this formula, which is a squared minus b squared. So we know that a squared is 36, and we will minus 16 from it. So this will be equal to square root of 20, and we need to get the decimal value of the square root of 20 for you to be able to locate it easier on the graph or on the Cartesian plane. So this will be approximately 4.47. So we already have the value for A, B, and C. Next will be finding out the value of your vertices. For the vertices, we have V sub 1 and V sub 2. And since we are dealing with horizontal ellipse, we will use these formulas. So this, and this. So for V sub 1, what you are going to do is to value your h first, or is to copy your h rather. Then we will subtract and add, since this is horizontal, meaning for your main vertices, you will just add and subtract values from h. So next will be putting the value of a here, then comma to give way for the value of your k. So in here, you just need to copy the value of your k. So v sub 1, that will be equal to negative 60, and v sub 2, that will be the value will be 60. So in here, it can be interchanged. So v sub 1 can be positive 60, v sub 2 can be negative 60. So it's okay if you interchange those values. So in here, so x is negative 6, so 1, 2, 3, 4, 5, 6, and y is 0. Negative 6, 0. That is your v sub 1. Then for your v sub 2, 1, 2, 3, 4, 5, 6. So this is your v sub 2, or positive 6, 0. Next will be the value of your co-vertices. So if on vertices you added and subtract on h, so in here you will add and subtract from k. So cv sub 1, that will be equal to 0. Then 0 minus the value of b, which is 4. And that will be equal to 0, negative 4. Let's locate it here. So 0, negative 4, 1, 2, 3, 4. So cv sub 1 is 0, negative 4. It's this point. Next will be cv sub 2, and that would be 0 and 0 plus 4, or simply 0, positive 4. So 1, 2, 3, 4. This point is your cv sub 2, or 0, positive 4. So next will be your foci. For the foci, we have here f sub 1 and f sub 2. So it will be the same on your vertices. You will add and subtract from h. So this will be 0, 0, subtract, add the value of your c. Then we copy the value of your k. So you won't be confused. So this will be equal to negative 4.470. and this will be positive 4.470. So we will locate it here. We will use different color so that you will see that this is a focus. So 4.47, it's along here. So this is your f sub 1, negative 4.470. F sub 2 will be around this part. So f sub 2, that will be 4.470. Next will be identifying the value of your major axis and minor axis. Let's start with your major axis. Major axis is twice of A, so meaning this will be 12. For you to know if your answer is correct, you just need to count the number of units from end to end on your major axis. It should be 12 units. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So meaning the value of your major axis is correct. Next will be your minor axis. For your minor axis, that is twice of B, and twice of B will be 8. Let's check if your answer is correct. So this will be 1, 2, 3, 4, 5, 6, 7, 8. So the value of your minor axis is also correct. Then to graph this, you just need to connect all of the vertices. You shouldn't include the foci in tracing your ellipse since it will only show you how elongated your ellipse will be. So this is now the graph of your ellipse, and these are the properties of your ellipse. Let's proceed with your second example. On your second example, we need to know if this is vertical or horizontal first. So the highest denominator comes with y here, as you can see, as you can notice. So meaning this equation is a vertical ellipse. So you just need to identify the highest denominator and that's it. You will know if it's horizontal or vertical. To identify the center, it's just the same with identifying the center of a circle. So this is H and this is K. So if this is subtraction or if this is negative, you will get the positive value here and positive here. So in here you will know that H is 3 and K is 8. We will now locate it here on your graph. So X is 3 and K is positive 8. So 1, 2, 3, 4, 5, 6, 7, 8. So this is your center, which is 3, positive 8. The value of your a squared here will be 100 since this is the highest denominator. So square root of 100, that is 10. B squared is 9, and if b squared is 9, the value of b here is 3. Next will be finding out the value of your c. To get the value of your c, so that will be the square root of 100 minus 9. That would be equal to square root of 91. In decimals, square root of 91 is 9.54. So we already have the value of a, b, and c. So if this is vertical, you will do the total opposite of what we did on the first example. So to find the vertices, so v sub 1 and v sub 2, so we copy h, comma, so we don't subtract since this is not horizontal. Then we copy k, then that's the time that you will subtract and add the value of a. So v sub 1 will be equal to 3, negative 2, and 3, positive 18. We locate it here. So v sub 1, so 3, negative 2, and v sub 2, 11, 12, 13, 14, 15, 16, 17, 18. So let's check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So this is your V sub 2, which is positive 3, positive 18. Next will be your co-vertices. So for your co-vertices, it will be the opposite. So we copy H, which is 3. Then we subtract and add. Then the value of your B, which is 3. Then just copy the value of your K, which is 8. Then we will simplify. So this will be 0, 8, and 6, 8. So we locate it here. So this is CV sub 1, which is 0, positive 8. And CV sub 2 will be this part, which is 6, positive 8. Next will be your foci. For the foci, so f sub 1 and f sub 2, you will do the same with the vertices. So we will add and subtract on k. So this will be 3, then copy k rather, then add or subtract add 9.54. Then we simplify, this will be 3 and negative 1.54. Then f sub 2, that will be 3 and 17.54. So to locate your foci, so negative 1.54, this will be on this part, f sub 1. Then f sub 2 will be on this part. Then we identify your major axis. So twice of A, that will be 20. If you count it from end to end, that would be 20 units. Minor axis will be 6. So from end to end, that will be 6 units. And your graph here will be this. So as you can see, the more your foci is farther from each other, the more elongated your ellipse will be. So that is now the graph and the properties of quantity x minus 3 squared over 9 plus quantity y minus 8 squared over 100 is equal to 1. Let's proceed with your next example. Okay, on this example, we know that this will be a vertical ellipse since the highest denominator is with or comes with y. So the center here, we know that this is 0, 0, so meaning h is 0 and k is 0. For your a, so that will be the square root of 169, which is 13. B is square root of 49, which is 7. So we just need to write A, B, and C here. And C, that will be equal to the square root of 169 minus 49. And that would be equal to the square root of 120. So let's check what is the square root of 120. So the square root of 120 is equal to 10.95. So we already have the value of your A, B, and C. So since this is vertical for your vertices, so V sub 1, we copy H. Then we subtract the value of your A, which is 13. So V sub 1 is 0, negative 13. By the way, let's locate the center here first, which is 0, 0. V sub 1 is 0, negative 13. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So this is your V sub 1. And for your V sub 2, that will be 0, positive 13. Because we just need to add 13 to 0. So this will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. V sub 2, 0, 13. For the co-vertices, so CV sub 1 and CV sub 2. So CV sub 1 will be negative 7, 0. We just need to minus 7 to 0 or your H. And positive 7, 0. So we locate it here. 1, 2, 3, 4, 5, 6, 7. So this is your CV sub 1. And CV sub 2 is positive 7, 0. For your foci, so F sub 1 and F sub 2. So this will be 0 since this is vertical. Then negative 10.95 and positive 10.95. So I will just use different color for your foci. So F sub 1, negative 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.95. So it's around this part. And your F sub 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, around this part, which is 0, 10.95. For your major axis, it's twice of A. So twice of A is equal to 26. I will write it here. It's your major axis. For the minor axis, it's the twice of B, which is 14. Also, then we will graph it here. So this is the graph of your ellipse. Let's proceed with your fourth example. On your fourth example, you will know that this is a horizontal ellipse since the higher denominator comes with x. So we write here that this is horizontal. And the center would be positive 3 and positive 9. So h is equal to 3 and k is equal to 9. Your a here is the square root of 49, which is 7. B here is 2. So to get value of c, so that will be the square root of 49 minus 4, and that would be the square root of 45. And in decimals, the square root of 45 will be approximately 6.71. So the center here is at positive 3 and positive 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is now your center. Then your vertices, since this is horizontal, we will add and subtract value of a on your h. So this will be the value of your h here is 3. Then subtract add the value of a is 7. Then we copy k. So this will be equal to negative 4, positive 9, and positive 10, positive 9. So negative 4, 1, 2, 3, 4. So it's this part. So V sub 1 is negative 4, positive 9. So 4, 5, 6, 7, 8, 9, 10. And this is your V sub 2, which is 10, positive 9. So CV sub 1, CV sub 2, we copy H here, we copy K, we subtract and add the value of B, which is 2. So this will be 3 positive 7, and this will be 3 positive 11. So CV sub 1, 3 positive 7. So 1, 2, 3, 4, 5, 6, 7. 3 positive 7. And CV sub 2, so this is 9, 10, 11. So CV sub 2. For your foci, so this will be F sub 1 and F sub 2. F sub 1 will be 3 copy H, subtract add 6.71, then copy K. So this will be equal to negative 3.719, and this will be 9.719. We locate it here on your graph. So negative 3.719. So 3.71, it's around this part. Then 9.71, it's around this part, F sub 2. Then we will graph it or connect the vertices. So this is the graph of your ellipse. So suppose that's an ellipse. Then the value of your major axis, that is twice of A, which is 14. So from end to end of your major axis, that would be 14 units. And for your minor axis, from end to end, that will be 4 units. Let's have your fifth example. For your fifth example, what we have here is x squared over 64 plus quantity y minus 8 squared over 9 is equal to 1. So in here, we know that this will be a horizontal ellipse since the highest denominator comes with x. And your center here would be 0, positive 8. So meaning h here is 0 and k here is positive 8. So the value of a here is the square root of 64, which is 8. The value of b here is 3, since 3 is the square root of 9. And for the value of your c, that will be the square root of 64 minus 9. And 64 minus 9, that would be the square root of 55. And the square root of 55 would be approximately 7.42. So we already have A, B, and C. So since this is horizontal, so for your vertices, for V sub 1, that would be H minus A and H plus A. So since H is just 0, we write positive 8 here and negative 8 here. Then we just copy K, which is 8. We can now plot the points here, by the way. So 0, 8. So 1, 2, 3, 4, 5, 6, 7, 8. This is your center. For V sub 1, that would be positive 8, 8. So 1, 2, 3, 4, 5, 6, 7, 8. So this is your V sub 1. And for your V sub 2, that would be negative 8, positive 8. So it's on this part. V sub 2, negative 8, positive 8. For your co-vertices, so CV sub 1, CV sub 2. So copy H, then for K, so that would be 8 minus 3 and 8 plus 3. So this will be 0, 5 and 0.011. So we just plot it here. So 1, 2, 3, 4, 5. So this is your CV sub 1. Then CV sub 2, 6, 7, 8, 9, 10, 11. So CV sub 2, 0, 11. Okay, there. For your foci, so this will be f sub 1, f sub 2. You just write negative 7.42 here, then copy K, positive 7.42, copy K. It's because your H here is just 0, so we just put here or write here the negative and positive value of 7.42. So for the foci, we plot it here. So negative 7.42, it's around this part, f sub 1. F sub 2, it's around this part. Okay, there you go. Then for your major axis, that would be twice of A. So that would be equal to 16. So we check if it's correct. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So that's correct. Okay, next would be your minor axis. It should be 6 units. So we count it here. 1, 2, 3, 4, 5, 6. So it's correct also. Then we connect all of the vertices. And that would be the graph of your ellipse. So this is the graph of your ellipse. So let's have the final example here. So for your final example, we have 4x squared plus y squared minus 32x plus 4y plus 64 is equal to 0. As you can notice, it is not on its standard form. It's on the general form of a conic section. So in here, the first thing that you have to do is to convert this first into its standard equation. But we will answer it on the next video about ellipse. So on part 2, please do expect that we will have this kind of equations, and I will teach you how to convert general form to standard form. So you can try to answer this and check your answer on part 2 and to see if you already know how to do this and you can do it by your own. So that would be all for today. That is our Math Minute. Please don't forget to subscribe and hit the bell button for you to be notified every time I upload videos. And that would be all for today. Thanks for watching.